one other thing that we can use, and I don't know if you would call it evaluating trig functions or just kind of finding other trig functions. Just given information that you have, how would you find the others? I would typically do this with a reference triangle, given the information that we have. So if I look at this and I think to myself, okay, I have sine of the angle is 5/13. The angle is between 0 or pi over 2 and pi. So basically the angle is in the second quadrant is what that's saying. It's asked to find the cosine of the angle and the tangent of the angle. And we're going to do this without finding what the angle is. 5/13 is not one of our special triangles. It's not one that we can find easily, but we can still find what cosine of the angle and tangent of the angle are without having to use inverse trig, find out what the angle measure is, and go from there. So realize that you have a reference angle. The sine of that angle is 5/13, which means your opposite is 5 and your hypotenuse is 13. Using the Pythagorean theorem, we know that 5 squared plus this other side, we'll call it b squared is equal to 169. And if I solved that, that means b is equal to 12 using the Pythagorean theorem. So now that I basically have a right triangle, I can find cosine and tangent easily. The cosine of the angle would be the adjacent, which is 12, over hypotenuse, which is 13. And the tangent of the angle would be the opposite, which would be 5, over the adjacent, which would be 12. You can do this once you set up your reference triangle. So drawing that little picture is going to be really important. So we'll do another example. I'm in the third quadrant, so I have a triangle down here in the third quadrant. Here's my angle. Cosine makes sense that it's negative because cosine is negative in the third quadrant. So the cosine is going to be 5/8. So that means adjacent over hypotenuse is 5/8. So I need to solve for the missing side. So basically I have 64 minus 25 equals b squared. So b squared equals 64 minus 25 is 39, which 39 is not a perfect square, nor does it have any perfect squares that multiply in it. So we just write it as the square root of 39. Leave it as a nice exact number. So to find sine of the angle would be opposite, which is that square root of 39, over the hypotenuse, which is 8. And the other thing we can do is if we know one of the angles and we know what quadrant it is in, we can find all the other 5 without finding what the angle is. So our last example here, we're in the third quadrant again based on between pi and 3 pi over 2. If our angle has a cosine of square root of 5 over 3, that means our missing side is 9 minus 5, because square root of 5 squared is 5, equals 4. So this side must be 2. So knowing that, the sine of the angle would be equal to 2/3. However, remember we're in the third quadrant, so tangent's the only thing that's going to be positive. So that's actually going to be a negative 2/3. Tangent's going to be positive. That's going to be 2 over the square root of 5. Square root of 5 over square root of 5 is going to actually be 2 square roots of 5 over 5. So now that you know those 3, you can find the reciprocal angle or angles easily. So matching with sine would be cosecant. So that's going to be negative 3/2. Matching with tangent is going to be cotangent. I'm going to go back and actually use this. That's not rationalized yet because I can just write it as the square root of 5/2. and we're just missing secant of the angle, which we're going to flip what we originally had. So we're going to have negative 3 over the square root of 5. So let's rationalize. And we're going to get a negative 3 square roots of 5 over 5. So just knowing one, you can find all 6 actually.